In the last lesson, we learnt that we could identify various cations by carrying out the flame test. In this lesson, we're going to learn that we can also identify metal cations by examining the precipitate that forms when sodium hydroxide is added to a solution of that cation. So we've got a dilute solution of sodium hydroxide here. Let's write there, diluted. And the general equation that's going to occur when we add the solution to each of these various metal salt solutions is the following. So we're going to take sodium hydroxide plus a solution of the metal salt. Okay, so we'll write aqueous there. And that's going to form a metal hydroxide precipitate. Right, so we'll do a down arrow there for precipitate plus an aqueous solution of a sodium salt. Let's just move that along a bit, fit in aqueous there. So in this test what we're basically doing is we're forming the metal hydroxide, and by examining the colour of this metal hydroxide and its behaviour we can determine which metal cation is present in each solution. So the metal cations that we're going to observe in this case are the Cu2 plus ion, which gives this kind of bluey green solution, the iron 2 plus ion, which gives a light greenish solution, the iron 3 plus solution, which tends to be a yellowy brownish colour, and then the calcium 2 plus ion, the aluminium 3 plus ion, and the ammonium plus ion. So these three solutions are all colourless. So let's have a look and see what happens when we add sodium hydroxide to each of these cation solutions. First of all, the copper 2 plus, we'll get a precipitate formed, which is a light blue colour. Right, so this just light blue precipitate. Now I'm going to take this as an example here just to write out a symbol equation for this reaction. I'm not going to do it for the other 5, but just so that you can understand this generic equation here. So in this particular case what we've got is sodium hydroxide plus copper sulfate. For example, this could be a solution of copper sulfate or copper chloride. I'll just choose the copper sulfate there. Again, aqueous. These are all, I ought to put that aqueous there as well, really. And that produces our insoluble precipitate, CuOH. In this case, it's copper hydroxide plus the aqueous sodium salt, which will be sodium joining on with the sulfate group, so that will be sodium sulfate. Okay, so we need to balance that equation, and to do that, well, we'll put a 2 here, and that's in order. Okay, so this precipitate here is insoluble copper hydroxide. Now, when the sodium hydroxide is added to the iron 2 plus solution, we get a darker green precipitate. It's normally classed as muddy green, a sort of almost greeny browny colour, okay, like that. Okay, we'll put sort of muddy green, sludgy green is also used, to describe this precipitate. Okay, so that's the iron hydroxide precipitate, FeOH2 for the Fe2 plus ion. When sodium hydroxide is added to an Fe3 plus ion solution, then we get a rusty brown coloured precipitate. Okay, that'll be FeOH3 there, because this is the iron 3 plus. Now for the calcium, I'll edge this in black, but we're going to get a white precipitate formed, right, and that's CaOH, calcium hydroxide. Oops, I should have put a down arrow there. Apologies, this and an AQ. Suddenly realised that. Excuse me. And again, when sodium hydroxide is added to the aluminium 3 plus ion solution, we also get a white insoluble precipitate. But the way we distinguish this from the calcium ion solution is that if you add excess sodium hydroxide to this solution, then the white precipitate will dissolve. So that's the important caveat here. White precipitate which dissolves on excess NaOH. So you need to remember that one for aluminium. Now finally, the ammonium solution, well, when sodium hydroxide is added to the ammonium solution, no precipitate is formed, but you will notice on gently heating this solution that ammonia gas is released from the test tube. So you write no precipitate, but on heating you get ammonia gas. That's NH3, not NH4. NH4 is the ammonium ion, so we're going to get NH3 ammonia liberated on heating, and you'll probably immediately know the smell of ammonia. It's got a very distinctive, unpleasant, sharp smell, but that can be tested with moist litmus paper. So it will change moist red litmus to a blue colour, indicating the presence of a strong alkali. Okay, so those are your cation tests using sodium hydroxide.